Okay, so some of you might have seen the videos I've put up where I show the most recent version going through all the levels, and like the 9x9 pack took like 2 hours to go through all 30. So I kind of expected it to take that long, but I was just curious. I was going to make another video showing it like a little bit more of sort of how it finds the paths, like by printing out the board at each stage, just for like the smaller boards, and sort of go through that. And then while I was in the middle of like just testing and sort of looking at that myself and figuring some stuff out, I noticed something strange. It wasn't actually catching all the loops that it was meant to catch. So if we just jump over to the code, so here's the code right here. Now, actually I've already edited this code, so it's not going to show it very well, but we'll see. So there's constraints check function. Yeah, this constraints check function right here is what I've changed. If you check the last time I showed you this code, this part right here was inside of this if statement. So basically what was happening was it was only checking if we had a loop, if the loop that, so if the square that was connected to 3 parts was an end. But so basically if we go to the board right here, so it would catch loops that, for example, this right here now is a loop, but it wouldn't catch it because this bit's not actually an end. So it would get away with making a loop like this without catching it, but it would catch loops that, so how do we make one of these? So basically if it was something like this, that it would catch because this bit right here is an end and it's connected to 3 other sides. So it would catch certain loops, but the majority of loops it wouldn't catch. And I thought it was quite weird. It took me a little while to figure out, but basically the way you fix it is just by taking it out of this. Well, it didn't actually take me that long to figure out, but you just take it outside the characters with ends if statement. So now I've just got an if it's not a blank square, because we don't care about these blank ones. Then we need to check if we've got a loop. So once I did this, I was curious, like what sort of speed improvement do we get? So I just ran it on the 9x9 level 2, which is the board you just saw, like this one right here. Now, in the video that's just been put up, or might have been put up yesterday for you, the level 2 and the 9x9s took 11 minutes to run, like a little bit over 11 minutes. So what we're going to do now is, I'm just going to show live just how much of an improvement this is, because it's actually pretty amazing how much of an improvement this makes. And then once we've done this one, I'm going to do another level. I've already done this one, so I do know how long this one's going to take, but we're going to do another one after this, because like I can't imagine any of you have actually watched the entire video. That's pretty ridiculous if you have. But if you sweep through the video just to find, say, the longest board, there's one in there that takes like, I think it's 1,600 seconds, something like that. So close to 30 minutes, not too far off 30 minutes to solve. So we're going to try that one because that's the longest board I've tried so far. And there you go. So we found a solution here in 35 seconds, which is like, so we say that's 30 seconds, like half a minute, and the other one took 11 minutes, just over 11 minutes. So that's a hell of a lot faster. Now, let me just find this other level. I think it was level 17, but I'm not certain. Yeah, it looks like it was level 17, and it took 1,650 seconds to run. Well, 1,647 seconds. So if we just go to level 17, so this one right here, and if this takes any longer than like a minute, I'm probably going to end it, but I'm expecting it to probably take around about 30 seconds like the previous one. So guess we'll see. But yeah, it just shows with like these few small what did I call them? Constraints. These few constraints that I've implemented into this recursive loop. We can get the computation time down like insane amounts. So I keep talking about how I'm going to add all this old logic in, but every time I go to add it, I find some new small improvement I can make to this one. So once I do eventually get them both mixed together, it will be pretty fast. I would imagine it can solve all these in like 5, maybe 10 seconds each. And there we go, we got a solution. 49 seconds, so pretty impressive when you consider it previously took like 1,600 seconds. So we could probably do all the 9x9s now in like a very reasonable time of like just a couple of minutes, probably like, I don't know, maybe 15-20 minutes to get them all done. So yeah, there was an 8x8 that took a while as well, but I can't remember which level it was and I can't really bother to find it live on video. So yeah, just thought I'd post this update. The code, as always, will be up on GitHub, this new version. And then hopefully I don't find any other silly bugs or anything, and I can start implementing the old solution, sort of find like the force moves and all that good stuff. So yeah, subscribe if you want to see more, like the video if you liked it, leave a comment if you've got any suggestions or whatever, and thanks for watching. I'll see you in the next video.